problem that Amazon delivery sometimes took 2 days, and this is a problem for the people who run out some stuffs middle of the night or when they need, and they find that this problem only can solve if they deliver something within an hour. So it's a big problem for the customer to get the delivery very quickly. Whenever this kind of problem is found in Amazon, you can think some small company, even for some small company, you find a problem, and then to propose a solution, to build a solution or feature, you need lots of alignment from your top leaderships, your like next level and next level and next level. You need some proposals, you need some approval and permission to go ahead with this kind of findings. But in Amazon, it's very simple, very easy. But so coming back to this story, they find this problem, and they don't wait for their VP to prove this solution to implement. They create a small solution within their teams with just for a small area to cover with 10 delivery man and like small cart and like very small scopes. What is the purpose of this story is basically anyone inside company like Amazon can make decision to solve a problem, but how can they validate his decision is aligned with company? That's why they follow the leadership principle. From this initial plan to build a solution that is actually comes from three major Amazon principles we are following inside our company. Like problem, who find fast, he own the problem on behalf of company, and then they build a solution that is biased for action. And when they build it inside like very small scope, it is actually mean the frugality. By following this kind of principle, actually every idea can see the light, every idea can get the like initial scoping or initial proof that it solves the problem. But when some like heroic idea get approval, then it is comes to the biggest challenge to scale this idea at Amazon scale or million billion scale. That is the time I saw from my experience actually followed some mechanism from very ground up or hands-on ideation. When it's proof, then Amazon follows some mechanism to scale up this idea. We have three major pillars for this kind of scaling. I want to go on this direction. So one of the first pillar that Amazon follows to scale up any idea, to first ask this question, is this one is two-door decision or one-door decision? So what is a one-way door decision and what is a two-way door decision? You can think one-way door decision is there is no buyback, there is no reverse way to invalidate the decision. You can think like, okay, someone comes with the idea that needs 5 billion investment. If you invest this amount of money and the idea is not working, then it's failed altogether. That is kind of usual example of two-door decision. Amazon always encourages to take two-door decisions. Two-door decision is basically you always have an option to reverse your decision that you can self-correct your mistakes. To maintain the two-door decision, Amazon encouraged to reduce the number of people involved to make these decisions. Amazon's usual setup is like the team size, we call it two pizza size team. Basically, the people, whenever making decision or building any solution, it's divided in a very, very low granular way and go low granular size, maximum 10 peoples in a team to make a decisions or to build the systems. Every team divided in at least 10 peoples. How this helps to move faster or helps to establish the mechanism Amazon follows is reduce the number of decisions and make the team faster. One of the another thing that I see in Amazon they follow very, very strictly is very frequent follow-up within a small group of teams. So when any project started to build, it is willing to follow up, if possible, every single day, if not every week. That they call it WBR, weekly business review, within the team. So whenever we are middle of something from the ground up to delivery, every week there is some review that helps team to move faster. And something that I'm running out of time, but I want to mention one mindset that Amazon follows very strictly is day one culture. We call it day one culture. So everyone in Amazon, they make a decision like it is their first day. It is their day one. And to cut the decision tree, like it is very important to follow this one. And for the presentations or like how we communicate with our leaderships, Amazon follows some documentation style that I can see it's a good way. We don't usually use slides or like long presentations, but in Amazon, we use one pager, like something very, very short and brief, because one quote Amazon used that like in slide, there is a fancy way to present, but and noisy thinking. So one pager is kind of a very brief explanation of your ideas to communicate with your leaderships. In terms of growing inside this high scale company, I can see like the first day at Amazon till today, I learned so many things about making decisions and making mistakes and self-correction. So these leadership principles is self-explanatory. You can find it anywhere. And these are the thing I am learning. I'm learning these leadership principles in details by doing all of these things. So that is the brief explanation of like how Amazon make decisions and why there is no layer between making decision on behalf of yourself and then how we can communicate. It's a very short time to explain in more details, but I am happy to take any question if anyone.
हमने जान আমি কোশ্চেন করব Mr. Dapchandan, can you hear me?
Yes, please.
Any problem? We can't hear you.
Sorry, is there any question? I'm waiting for the question.
The question from audience. Do you have any question?
Hi. My question is like a company like Amazon or Google, like how you guys develop a software or let's say Google Drive or Amazon App Store. So how you guys like update that thing? It's like, do you guys write all the code up to down? I mean, start from zero to at least zero to finish or what? It's like I want to know the process actually.
Okay. It's a very curious question. How actually we work? What is the like day-to-day job as a software development engineer at this scale of company, right?
Yes, yes.
Is that your question? Okay, nice. So basically, as I mentioned that we are at max 10 people in a single team. We work in a project, but that is a part of big project. If you ask, we write code from the scratch. No, we follow some designs from the leaderships, and we just okay, let me put it in even simpler way. So the way we work is we get the design and we convert this design into code, and then it goes to the code review and from the senior engineers and principal engineers. So we are not working in a at all together because every project is huge and big, but we get a small part of it and implement on behalf of ourselves. So you can think about like from the Google Drive, you get only the notification service in your team. So you implement notification service by yourself. You are designing those, how you can design this part, and then there is a design review. After design review get approved, like just in review with the senior teams, if there is no comments, you are good to go to implement. And then depends on the size of your work. Sometimes we divide it like, okay, to implement this one we need 3 engineers, and then they just give, okay, these 3 engineers will implement this part. These 3 engineers then decide how they want to implement. To finally evaluate those implementation, there is some certain criteria to match, like it needs to be faster, it needs scalable and robust, that we all follow. But we receive a pitch of very small instruction, a small feature, and implement. Not like whole project implement by a single team. It's just a small part we received, and then we design and then implement. Is that your question, you answer you are expecting, or?
Yes, and another thing,
Yeah.
how do you debug bug? I mean, when I create a project, like I have some small project, so So when I create a project, I practically run that project again and again so that I can identify the bug. But when you working with a project smaller part, like a fraction of a project, so how do you debug that thing? Like you cannot run that project or run that code at your system, right?
Okay,
Mainly,
so what I understand, how do we test the whole project when we are implementing a small part, right?
yeah.
So there are multiple way to test this one. It's started very beginning with writing lots of unit test, and each unit test there is some different kind of coverage like line coverage, branch coverage, and so on and so forth. After that, there is an integration test we follows. Basically, when you test your service, all of the other service, you can think as a very abstract way. You can call, like, let's say you have three small services that build one big service. You don't need to test other two. You just need to test on your service. Testing helps in this way. So yeah, I can feel your curiosity, but testing is very important in this scale. So there is multiple layer of testing. We started from the unit testing, then it goes on integration testing. After that, there is lots of tests, and the rollout doesn't happen at once. There is some A/B testing, which we follow like with small load to bigger load. But to answering your question, to test the whole project, we use integration test. And there is a lots of way. Internally, Amazon does follow some internal framework that you can call other service, get the output, and you just test on top of that. Your service is working properly, whatever you promised to deliver. But following the integration testing, you can test your service.
Thank you.
Any more question?
So my question is, as a software developer working in big tech companies, how much do you take importance in optimizing code that runs on low resources in the servers or any kind of machines? I mean, how much do you emphasize the code optimization in low level is to
Like how much emphasis I give to write
optimize code? Yes.
Okay. So if optimize code means resource wise, right? You ask.
Yes.
Okay. It's a bit tricky here because whatever the project I work, to be very honest, I literally don't have any resource optimization problem, because from my scope of work, the design comes from principal engineer. The decision is being made there. Like, okay, is this solution is already optimized or not? If you ask me from implementation perspectives, we follow the design doc that is already optimized. And writing code is not something you can optimize. It's the design. You will use how much caching, you will use what type of machine, and that depends on your BRD, means business requirement, like how much load you are expecting. If you expecting like millions of calls, then one type of design. If you expecting like even more call, then there is some other way to solve this problem, that is like something vertical scaling versus horizontal scaling. So that is a design steps, not implementation steps.
So my other question is pretty tricky. Every programming language has their pros and cons. Like with C, C++, you have total control over the memory, and in Rust or Golang, you have automatic garbage collection. Which programming language does these big tech companies prioritize the most in recent years?
Okay, so there are three types of decisions when you choose the technology. One, you are the first person writing or deciding the technology. Then you have control, you have like own freedom, which direction you want to go. Another one is you just join that is already built, like you are joining a product that is already up and running. Then you have, I would say, little flexibility to go here and there because you need to follow what is already in the systems. Another one is extending the feature. There is little bit more flexibility you can decide. From my experience so far, I work 3 different systems in Amazon, and most of the time, if I'm writing a new service, it's my call, whatever the technology I want to choose. But if not, then I just need to follow whatever the implementation there is. Like I can't change Java code package to Python code package just because I think it is faster, because I need to consider the dependency as well. And I need to consider, like, there is a trade-off, how much you are making faster versus how much in time and resource you are investing. So you get the idea, right?
Yes, I think it means that if I can think that this is best for me, then I will do my best with the thing that I can do. And if things I can't figure it out, then I will follow just the protocols, right?
Yes and no. Like, for example, if you see the massive or like the significant up from changing one technology to another, Amazon always like encourage to newer technology, but you need to make the trade-off, I would say. If it is good, it is making customer, like it is making the system faster, then yes, definitely you have option to go.
Okay, thank you very much. And
Okay.
I have no questions now. Thank you very much.
Thank you. Any more question? Okay, Mr. Abdul, there is no question. Thank you, Mr. Raksan Danish, for sharing your views and ideas. Okay, thank you.
Thank you, everyone.
Mr. Shakil Ahmed, can you hear me? Now, another session, that is Mr. Shakil Ahmed, who is working as a senior software engineer in Google. He completed his BSc from CSE in Russian University. Then he joined Innosis Solution as a software engineer. Then in 2022, he joined Google Ireland. I am requesting Shakil Ahmed share his slide. Okay.
Hi, can you hear me?
Yes, sir, we can hear you.
Okay. Give me a second. Okay, so I'm Shakil Ahmed, and I'm a senior site reliability engineer at Google. I will be talking about how we run a system that never sleeps. So there were, I was looking, the question I receive very often at Google is, how do we do like software updates how do we deal with bugs that doesn't cause an outage. For example, in many systems, what we see is when people are doing a software update, then the users are kind of like kicked out of a system for some minutes. But if you notice, Google, Facebook, or Instagram, you will always notice that all the feature deployment almost never cause an outage. And very rarely you will see that there are outages that cause the whole system to go down. So how does it work? One thing here is the 100% uptime is a myth. There are two different interpretation of availability. So if you notice, there are something called users perception, or like the visible impact, where you notice that you are always using Facebook or Instagram or Google search, but in reality, behind the scenes, there are always failed deployments. There are bugs in the system. There are often machines that are broken and it can't actually serve your request. So in distributed system is almost never online. It is almost always in a partially broken state. So to design a system like this, we follow some principles. The first principle that we follow is called zero trust. So the zero trust principle is very simple. It just says that if you do a system design where you gave a human some responsibility, it will never work. You should always assume that humans will make mistakes and human may act maliciously. Google has like thousands of employees. Even with very strict background check, you can always hire the wrong people. Sometimes what can happen is you are traveling another country and someone threatened you to get your credential. So the systems are designed in a way that a single can never bring a whole system down. So this is like the first principle that we follow. The second principle is called zero blame principle. It is kind of an extension of the first principle as well. This one says a human is never at fault. So whenever an outage happens, whenever you did something wrong, it is never a human's problem. If a human can bring down a site, then the process allowed them to do so. So whenever we design a system, we also include this in our design, that a human should never be able to bring down a system. Okay, so those are the two principles that are sufficient, and you will see shortly like why. So generally, a system is better. It almost always works. Usually, the system fails when we introduce some kind of changes. Generally, there are two sorts of changes. There are thousands of employees, so they are almost always writing some code and pushing them in production. Sometimes there are external events like Black Friday deals or an World Cup is happening, or there are some sort of event which is causing a lot of people to check the, say, breaking news. This will increase the amount of traffic to the system, which is also like an input for the whole system. And this causes failure. So the golden rule we follow for change is to always assume that whatever change I am making to the system will break the system. So it's not that we just assume that it will. To defend against this, what we do is we divide the system in many dimensions. For example, one of the common segmentation principle is location-based, where you can see the whole world is divided in many, many different segments. And in each segment, we have a separate deployed instance of a service which is never depending on, say, another region. So this is like one of the location-based segmentation that we do. For example, if two of you have two different Gmail accounts, even though both of you are using Gmail, it could be the case that you are not using the same Gmail. It could be part of two different location or two different instance. And if you say move from Bangladesh to US, then it is possible that your data will be migrated from one system to another transparently, while you have the perception that you are using the same service anyway. But this is rarely the case. The second type of segmentation we do is user-based. So user can be arranged in separate groups by, say, popularity, age, or other kind of behavior. When we buy hardware, we also never buy the latest technology, as people might believe. Generally, like if you buy the same hard disk or like the same CPU, if an unknown bug in there, it can bring your whole system down. So what we do is we mix and match SSD, HDD, CPU, and other kind of hardware from different vendor and from different generations as well, so that even systems down. Introduced in the is marked as red here. So if there is a bug in your change, in that case, these two regions will only go down while the whole world is still online. So generally, it works like this. So we enable a new feature, or we push a change only to a very small fraction of traffic. And generally, this traffic is people who are adopting a new feature, and a lot of them are just internal users, like that could be other Googlers. So we always kind of like get a latest feature first. And then after an observation period, then we start to deploy this change in more and more locations and more segments. These two mechanism like give us. So generally, we build a system in a way that the system can notice whether something is wrong with itself. And there are protocols which are triggered to get the system back to an healthy state. And they are generally like automatically triggered. And most of the time, a human do not need to get involved. Sometimes if a failure is happening for a long time and usually very early in the rollout phase, then what can happen is a human user or a human operator may get paged. So when a human operator get paged, then investigate what is going on and try to figure out. So we generally investigate what is going on, and the first thing we try to do is to stop the bleeding. So what does the stop the bleeding means? So the stop the bleeding means that we try not to break more parts of the system whenever we detect an outage. For example, if we detect this outage at 5% traffic, then the first thing we do is we disable any further progression, and then we do a rollback to disable this new change and go back to a known healthy state. So that's like the first thing an operator do. And after that, we go for a deep dive. We try to figure out how did we end up here? Did we make a wrong assumption about, say, user or traffic pattern? Did we made a design error where the assumptions were correct, but the design we made doesn't actually solve the problem correctly? Or is there an implementation bug? Like the design we were handled was not implemented properly. So we do a deep dive and try to figure out what was the root cause. After the root cause is identified, we generally have two directions. Sometimes we just fix the problem if it is very small. But if it was noticed by some external users like you, then it is mandatory that we do a postmortem, because that means it was a large, impactful incident that was even noticed by you, which is bad peer and also failed engineering. So in the postmortem, we look into the system very closely. We try to figure out the timeline of event that got us here. Then we actually take some, like we write down some action items so that this kind of things can never happen again. At Google, we strictly follow like one principle. One outage can trigger for a single region only once. So if you notice that the same incident was seen twice and it happened for the same region, it is a big engineering failure, and it is a very easy way to get noticed by your, say, BP or very senior persons. So it is very important that when we are writing a postmortem, we enforce the rule that human error is never the root cause. We can never say that we will we will train our operator better, didn't push a button. So this kind of things are never a problem, never the problem, because if a system depends on a human, it will always fail. So so this process almost always works. There are some special cases where things can break in a way that we can control with this process. One of the example is called the query of death, where an outage or a bug doesn't trigger unless someone sends some certain input to the system. So when this happens, our phased rollout cannot detect this because that part of the code was never triggered or that data was never sent before a human can do it. It is not always possible to kind of like send all the possible sets of input to a system. So it mostly find all the bugs, but not everything. And second edge case is called like time bomb, where an outage can only happen after a certain duration. For example, if there is a memory leak, maybe it takes a month to accumulate enough kind of like to lack enough memory that the system will break down. Or it could be a very data specific error. Another edge case is called the real-time systems. So imagine like if you want a news and you went there and you saw that the news is 7 days old. So the phased rollout system doesn't work for this kind of real-time systems where freshness are necessary. So the soak time is usually very small, in like in minutes. So to go from like 1% fresh data to 100% fresh data, maybe you can spend 10 minutes at max. And it doesn't provide sufficient kind of like time for an operator or for the auto healing procedure to trigger. And this is kind of like an open research area where people are trying different things and see what works. So to sum up, the reliability is kind of a feature, and it careful design where we do not give human any responsibility because we can't trust them. We also don't give a human any kind of blame, because when we blame people, they if they make a mistake, they will try to kind of like hide it. If we don't blame people, then they will try to surface it as early as possible, so other people can help them to fix the mistake, for example. We also never kind of like have a global system. Internally, every system is a set of many, many different small systems. So whenever something breaks, it can only bring down very small part of the system. We also make sure that we introduce change to the system in a progressive manner, so that the sharding works. So you can actually substitute like Google for like Facebook, Instagram, or any large scale system. And these are the principles that will keep your systems running for a very long, long time before any kind of global outage can happen. So that's all. If you have questions, I can try answering them.
Any question from audience? I have one common question. How the student get prepared for Google? What is the equipment procedure?
Sorry, can you repeat?
Repeat the question.
Hello, can you hear me?
Yes.
Repeat the question, please.
I have a common question from audience. How the student get prepared for Google, and what is the recruitment procedure?
I see. So it depends on like what you want to do at Google. One of the common role for most students who kind of like study computer science is to be a software engineer. So for software engineering, for say entry-level role, we mostly require people to understand data structure and algorithms, understand them. So that's like one general principle. And the second thing we follow is we want people to be likable. Because if you are not likable, Google is not going to hire you. It doesn't matter like how good you are. So for preparation, one thing you can do is try to learn the structure and algorithms, and try to learn how you can explain them with ease with people that you maybe know or maybe you don't know. So being able to clearly explain how you think is the first requirement of kind of like, say, passing an interview. The second thing want to do is to learn to respect people, which most people from, say, Bangladesh universities kind of like struggle a little. So I would say that try to, one of the things you can try is, if you know something, try to teach this thing to other people. Then you will learn to communicate more gracefully. Try to learn how to not escalate situation when you are kind of like encountering a problem with some other people that you don't like. So if you can practice these two things, I think you will also kind of like improve the likability part as well. Because when I'm interviewing someone, generally it is very easy to see if I hire him in my team, whether I will be happier or I will be more unhappy than. So this is like one of the things that we notice in the interviews. So if you notice this, you are never going to pass the interview, basically. So I would say that practice very hard and try to learn to communicate well with other people, even with the one which you don't like.
Thank you so much, Mr. Shakil Ahmed, for sharing your views. See you soon, inshallah. Now the final session. Now the next speaker is Dr. Gaji Saurabh Islam, working as a research and development engineering manager at Intel Corporation. He completed his BSc from Tripoli, IUT, Bangladesh. Then completed his PhD, published about 10 peer-reviewed journals. Then finally joined at Intel Corporation. I am requesting Dr. Gaji Saurabh Islam.
Hi, this is Gazi Islam. Can you see me or hear me?
Yes, yes.
Okay. Yeah, sorry, the camera just rolled down. I can see basically almost an empty room anyway. Oh, okay. Oh, quite a big room. Okay. Hi, should I go ahead? Or okay. Let's start. Okay, anyway, probably hungry as well. Back to my where I live. Anyway, I work at Intel Corporation in USA, which is located in Portland, Oregon. It's in the west coast of the United States. And by the way, you guys can hear me, right?
Yes, we can hear you.
Okay, cool. Thanks. Okay, anyway, as I was saying, I was traveling back, I was basically in the flight for the last 5 hours, and I kind of put some slides together in the flight that I'll go through in the next 5 minutes. And then basically you can ask me anything and everything, you know. Let me try sharing. This platform is quite new to me. Make it full screen. Yeah, let me just make it a little bigger. Yeah, the full screen is not working that well. Anyway, so my connection to Varendra University is through one of your professors over there, Arifa Fedousi, madam. I'm guessing she's pretty popular over there. Anyway, I went to school with her, school and college, Rajshahi University School College. And then after that, I went to IUT for electrical engineering. And then I taught there electrical engineering for a couple of years. And then was to United States for master's and PhD in biomedical engineering. And right after finishing that, I started working at Intel. When I joined at Intel, and when I applied to Intel, the only connection between my resume and Intel was they're looking for PhDs, and I had a PhD at the time. So anyway, I started working there, and since then I've been working there for the last 12 years. So anyway, I mean, how is it? What I do there is kind of like we develop the next generation computer processors. Like, I mean, every couple of years there are new computer chip is coming in the market, right? Like to follow the Moore's law, like each processor should have like double the number of transistors and so and so. And then you reach a physical limit, and then you it's not only double, you go like 3D and all those. So you get study all this in electrical engineering, I guess. But my job is like very tiny portion of that like when they develop a new type of processor, we test it and feed it back to the design team, so that they can improvise the design even further. And the work here is pretty good. Like at Intel, like we work 8 to 5, whatnot, and then it has a good work-life balance, and I mean it has a comfortable salary and stuff. So I guess like a lot of people who finish undergrad in Bangladesh, they come to grad school, and then after that they join to one of these multinational companies and work for the rest of their life. So it's pretty much like standard for all the folks. Um, so yeah, working here for 12 years was pretty fun, and until now, where the semiconductor business gets very cutthroat. So when we have to compete with everything, right? So when you go out there and buy a TV, like 30 years ago, my house had like a Sony TV or whatever. Now you go buy a TV, you don't have to pay extra premium for a Sony TV, but you probably get something cheaper, which works as well as good as Sony TV, right? So you might get a Samsung TV or LG or any other Chinese brand. So the same thing here. Like in the semiconductor industry, Intel was the leader of the semiconductor industry, but then and then there is TSMC that came up. So this is I'm just putting a comparison. Like at TSMC is the Taiwan semiconductor what is this called, semiconductor company or whatever, manufacturing company. So when we developed a new technology wafer, the cost to develop a wafer is almost $15,000 for Intel, where at TSMC it's only 9,000. And TSMC, and you can see that it's more expensive to produce wafer with Intel. So TSMC obviously got more and more market share. At one point, Intel used to have like almost 95% market share. Now we're only 7%. And TSMC produced like more wafer. They supply wafer all over the world. And you can also see that the average salary of a TSMC employee in Taiwan is like almost 50K, where in USA it could be like 100. So this is where the stark difference, we at Intel, we charge extra to produce something that other company can produce for even lower price. So that's when we had to take to stay in the competition, we had to be very competitive as well. So how we can do that? So when we ended year 2024, our worldwide total number of employee was 110K. And then this December, our total number of employees is 75K. So which is more than 30%. We had to go through layoff just to make sure we can reduce our cost and stay competitive with TSMC. And this is where we get to challenge my those people. Now it has 8. So how can I get done 12 people's work with only 8 people, right? So that's where artificial intelligence comes in, right? I mean, you can get more work done by using AI, and then basically it's not we're replacing people, but you have to be cost effective, and how we can achieve that. So, for example, even at Intel, like, there are many tools, each cost like millions of dollars, and we have like preventive maintenance for each of these tools. Like just like your car, like, if you have to change oil like after, or like what you call in Bangladesh, like mobile, right? You have to change it like, every 6 months or so. What if you don't change it? If you run it for 2 years, does it break your car or not? So that's what happening. Like, I mean, we have like all these multi-million-dollar tools, and we used to we used to do the preventive maintenance, which is very expensive in every at certain period. But now we are using AI, where AI can analyze the data, like, the tool health, and it can suggest when the tool need maintenance. It's not like, we just go on and do the maintenance. As opposed to in your car, like, whenever you see like, it's not running that well, then you change the oil, kind of something like that. We also test like, millions of chips every day and produce billions of data. And all this data, there is a team called device team, which analyze this data. There's like 150 people, and this data done with AI, like in a matter of seconds, and with literally with like 5%. So anyway, like, all of these uses of AI can be implemented in tech companies. Like, we also do like a lot of scripting. We do like make a lot of softwares, and now like, how AI is taking all the software engineers' job as well. But does it mean we need to stop everything and wait for AI to take our job? No. The reason is, even if you have AI, like, you need the expert in that field to let you know how to use it, right? I mean, um, like an example, if I want to monitor something, even in our work, and it needs to create an website where, it will have a chart where, like, all the tools data or something. I cannot just use AI to someone who actually knows, like, C sharp or C++, scripting, Python, and everything, so that that person can also judge like, how AI is producing that website and keeping the data relevant and all this, right? So we always need experts from that field. So it's not like, AI is taking our job, but like, it's helping us to do our job. So yeah, we did laid off a lot of people, but with the use of AI, what we can achieve, that we can achieve like a lot faster with people. So I mean, you're not actually replacing people, but you're achieving stuff faster, more efficiently with the people. So that's how AI is helping us to achieve. So you guys are just doing undergrad, so what you should do is you should be the very best at what you, so that you can always use AI to be, even better version of yourself and be more efficient. So anyway, I'm not sure whether all of this makes sense, but like, what I'm trying to say is like, you're doing your undergrad. After that, you'll probably go for a grad school, and then you work for some company and do something. But even then, they will need you to use AI in your own field. Okay. So I mean, AI should not be discouraging, but you should just use it at your own benefit, right? Anyway, I mean, this is all I put it in as a slide, but you can go ahead and ask me any questions. You know, I can open the floor for that. The name of the moderator who was running this session.
Any question from audience? Mohammed Johid Islam, moderator. You asked for moderation, moderator name,
Hello.
right?
Uh, sorry, I missed that. Did you ask anything?
One question from audience. So I can say that AI is old nowadays, and today's world is now based on agentic AI, who can drive other AIs to do the task. So how can we survive in the agentic AI age of agentic AI?
Um, so you're saying, AI is producing other AI to work in our
But
benefit, right?
now people used to large language model, but there is a new concept that companies are using, that is agentic AI. How can we survive that?
Well, you guys probably more advanced than us. Like, even at work, we don't use that much AI yet. Although I mean we should. So what I should say, like, in smaller companies where, AI has access to all the data, but all these companies where, particularly at Intel, where is not open to all, like, it is intellectual property. So we cannot just go ahead and use AI, like, ChatGPT or something. Like, I cannot, like, at work, I cannot just put in everything in ChatGPT. So we had to develop our own AI to be useful in our system, right? Just because of the intellectual property. So what I'm trying to say is, like, even though AI is kind of like everywhere now, but it's still quite limited use, and like you cannot just trust everything and put it on AI. Okay, so from outside, even though it looks very scary, but now it's not that scary. Like, you will survive, and if you know what you're doing, like, if even whatever you are, if you're an electrical engineer, if you're a computer scientist, whatever you are, if you're very best at your work, all these companies will. And maybe previously you had, like, 20 people working with you to do one job. Now you might have like 10 people, because you'll use AI to, fill that gap. So it's not never going to replace you, but it will just make you more efficient. Just like in, you're probably familiar with Moore's law, right? I mean, it's like in every 18 or 24 months, we computer chip shrinks so that you can, there will be, like, double the number of transistor in a chip, right? So with AI, it will not replace people. What it will do, it will probably get that done in, like, we don't even need 24 months. Probably in, like, 12 months, you can achieve the same result, right? So it will move faster, but like there'll still be people, and there will be AI and people together, and you use that AI.
Talking about the chips, I have a weird question: that is there any theoretical limit that chips will get no smaller than a constant amount? I mean, chip will no the chips will no will never get smaller than this. Is there anything? You just
There is, and that's where we got stuck. Like, so for the last 20 years, for Intel, it was very easy. You just, like, whatever your model, you just shrink it into half, and that will give you, like, double the number of transistor. And then, when we were producing 7 nanometer pitch, we saw that we were at that physical limit, and we had to invent something that is, not just shrinking, but go in 3D. So, in like, previously it was like one layer of chips. Now you have to go, like, from the same wafer, you can go from front and back. So, like, the metal layers goes from back, and then the all the silicon gate and sources that can be from the another side. So yeah, there is physical limit, and that's why we are, like, making a more and more advanced um, uh, silicons, so that we can overcome that limit. And Yeah, we're doing like cutting edge research, so there are like better silicons, and then some portion of Intel they are doing the quantum computing and stuff, right? I mean, once the quantum computing comes in, then it's like way faster, right? And there are other stuff as well.
You mean it's open of computing?
Yeah, it's still in research base. Like Intel is doing something in terms of like using semiconductor for quantum computing. There's IBM, they use some other technology, and like there's different technologies out there, and it's tough to say like which is what is gonna win. Um, but yeah, it will be coming in future. But when we are at school, we kind of see like there's so much stuff, like there's some during my PhD I did like a lot of research and all this, but industry is very stagnant. They're not very used to doing any big change, it moves very slowly. So whatever the cutting edge stuff you're seeing, it will probably come in like another 20 years, like not tomorrow, right? So it will be very similar to what you are using. It will, like, look at the iPhone, right? I mean, like for last 5 years, it looks almost same, right? So that's how the industry moves. It doesn't move like too fast. It moves. It makes a little bit of increment every time.
How is Intel made its GPUs more affordable? I can see the B series graphics cards are more affordable. Do you know any reason?
Sorry, I didn't get the question. Can you repeat, please?
The Intel B series graphics cards are more affordable than ever. Do you know the reason? I'm just asking.
Okay, so I mean, I probably asked this same question when I was interviewing for Intel, like 12 years ago. Like, hey, Nvidia makes such a good graphics card. Why Intel is not making some? So I mean, their focus wasn't that, and then Nvidia was a graphics card. Now they found that their graphics card is so fast it can be used as an AI chip. And now you see, like where Nvidia and where they used to be 10 years ago, right? So anyway, yeah, Intel is trying to compete with all of this, but they're a little late at like a lot of different games. Um, anyway, so to answer your question, like yeah, there is like visions. There is like sometimes you don't have the good vision or something, like where to get in next 10 years, and you try to do whatever you do the best and not get into something new. um yeah, and yeah, everything will be getting cheaper and cheaper eventually, right?
Thank you very much.
Thanks. Yeah.
Any more question? Okay. Thank you so much, Dr. Shoaib Islam, for sharing your busy time with us. Okay. Thank you so much.
All right. Thank you. Yeah, nice talking with all of you. And if you guys have any question, feel free to reach out. Yeah.
Okay.
Thank you. Bye.
Thank you everyone for bearing with us till now. And thank you to our esteemed guests for our very insightful and engaging sessions. And thank you to our chair for conducting this session. At this moment, I'd like to request Umar Madam to convey the crest to our Honorable Chair, Dr. Juhurul Islam Sir. With this, we are ending our industrial talk session 2. Our session 3 will begin in 20 minutes. And for this session, we have the guest of MD Mijanuddin, who is also the co-founder and chief executive of WeDesk, a software-based company of Bangladesh. So those of you who are very interested and looking for a job in software development field in Bangladesh, as you have to start from Bangladesh to reach out to Google or Intel level. So you guys are requested to stay in this auditorium and invite your friends who are very much interested to pursuing a job in Bangladesh software development industries. And we'll see you in 20 minutes. And after for that, now I'm finishing my work here.